scholars. Hello. नहीं जा रहा.
हाँ बोलिए साहब.
हाँ नहीं, इसमें कुछ मैसेज आ गया था, नहीं जा रहा था. Okay. So today we are going to study and discuss Alaukik Ganit. I have translated it as transcendental arithmetic. Because why it is Alaukik? Actually, the term is coined by Pandit Todarmal ji of 18th century. He has called it Alaukik because at that time it was so weird, it was so unworldly, it was so advanced that he has termed the name that it is out of this world. And that's why he has termed it as Alaukik Ganit. He himself went to Karnataka, studied the Kannada commentaries on Gomatsar and Labdhisar, etc., and translated it into Dundari, which is a dialect of Hindi. And not only that, but he wrote a very beautiful introduction how to study Alaukik Ganit and all that actually. The difficulty in studying this Alaukik Ganit amongst we people was that the notation, the symbolism used was very complicated. Very complicated. But at the same time, we must agree that it is the beginning of numerical algebraic symbolism in India, because in no manuscript earlier period we find such notation. This is first time we see in Keshav Varni's commentary on Gomatsar. And Keshav Varni was a scholar from 14th century, and he has used various symbols for various terms. For example, for Asankhyaat, for Sankhyaat, for Antarmuhurta, etc., various symbols. And then they were so complicated in appearance and all that, that people were not able to understand it properly. But what we are going to discuss today is that how to interpret them properly, etc. So, but before that, we will have to consider various aspects of this Alaukik Ganit. One more thing I want to make it clear, that at the end of 19th century, there was a great mathematician in Europe, Cantor, and he propounded a theory for infinity. I will say infinities, because he established that there is no single infinity, but there can be theoretically infinity of infinities, actually. So earlier he met with lot of resistance. People even discouraged him. People criticized him severely. Great mathematicians opposed him tooth and nail. And it went to such an extent that he has to be admitted to a lunatic asylum towards the end of his life. But whatever it may be, our theory, which is, say, about 800 years earlier of this Alaukik Ganita, which is propounded, it is very, very similar to the Cantor's theory of transfinite numbers. That there cannot be one infinity, but there can be many infinities. There can be many transfinite numbers, etc.
So, request to change your slide also.
I'm changing. I'm changing. I will change. I am just giving this introduction, and then I will come to the subject. So we'll consider Alaukik Ganit. What are the sources for this thing? Although Keshav Varni belonged to 14th century, his guru's guru, Nemichandra Siddhanta Chakravarti, belonged to 10th, 11th century. Probably with Nemichandra, this trend started using the symbolism, but we have no proof. The first proof is on the 14th century work of Keshav Varni only. But I am just sources what I am giving, because where it has begun actually, all these ideas, when they conceptualized, it began with Shatkhandagam. 2nd century by Bhutbali and Pushpadan. Yeah. I don't want to go into much details on this, but it has first time it has started using the term Sankhyat, Asankhyat, Asankhyata Sankhyat, Ananta and Anantananta. Then next, Aniyodhar Sutra, although I have mentioned 4th century, but in the 3rd century conference, 4th century, yes, it is okay. 4th century because in the 300 AD conference, Aniyodhar Sutra was first edited. And there, but it is not by ARITHMETIC, but other monks they have edited it. So Aniyodhar Sutra gives a very, very scientific treatment on the lines with Cantor, and just similar to Cantor. Of course, it cannot have that rigor. The mathematics was not that advanced at that time. So, but the ideas are very, very similar, as you will see very shortly. Then Tiloya Pannati. Tiloya Pannati by Jadivasaha. This is a 4th century work. I placed it 4th century work, but there is a lot of controversy about that because it contains some prose portion. It is mainly a poetic work, but it contains a lot of prose portions which are as late as up to 14th century. Then there is another Jiva Samas of anonymous author, nobody. Here, there is some advance on the theory of Aniyodhar Sutra. Then Gomatsar Jivakand, we take a leap. Gomatsar, Karmakand, Jivakand, and Labdhisar, and Triloksar. Triloksar is also a very wonderful work where a lot of mathematical principles, logarithms, the rules, etc. are propounded by Nemichandra Siddhanta Chakravarti. But I will be making great mistake if I don't mention Karma Granthas of Shiva Sharma. They may belong to 2nd century only, maybe contemporary with our Shatkhandagam. There also, but I find only mention of Sankhyat, Asankyat, Asankyata Sankyat, Ananta and Anantanant is there. Instead of about 27 terms we are going to come across, actually. Keshavarni first wrote commentaries on Gomatsar, Jivakand, Karmakand, and Labdhisar, and Triloksar also. And there he used his notation, and those are found in the manuscripts of that period. In 18th century, Todarmalji translated into Gandhari. One more biggest omission on my part, but I have deliberately done it. It is Veersen of 8th or 9th century, 8th and 9th century. He was a prolific mathematician. I may say greatest mathematician in our continent of that at that time, I can say. He has written 2 big volumes, commentary on Shatkhandagam, which is called Dhavala, of 72,000 sutras, and commentary on Kashay Pahud by Gundhara, which is of 60,000 sutras, where there is tremendous mathematics. But all over he assumes that the person who is reading these commentaries knows mathematiks. So he doesn't go into the rules, he doesn't go into proofs, he doesn't go into details, etc. He just describes that Varga Shalaka of this is in the Asankyat class, Varga Shalaka of this is in Yuktananta class, etc. All such terms he uses. But that will, of course, I can say the greatest Alaukik Ganit is found in Dhavala, 17 volumes, Jai Dhavala, 17 volumes. Okay. Yeah. Now, as we see, our Jain scholars, Jain saint scholars, have a great fascination for large numbers. These terms are very common, right from Shatkhandagam time onwards. Kodi, that is 10 raised to 7, Koda Kodi, Koda Koda Kodi, Koda, 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 Kudi. These appear in Shatkhandagam as well as Anuyogdwar Sutra, etc., and many more, much more than this. In many of our astronomical works, we find that number of stars in the family of one moon is equal to 66,975 Koda Kudi. That is about a 19-digit number. It is a 19-digit number. Then number of words in the Agamas. This is a very significant, I always mention this, that number of words in the Agamas, they have calculated as 2 raised to 64 minus 1, which is a 20-digit number, as I have mentioned here. Actually, this was derived from our famous binomial formula that n1 plus n2 plus n3, etc., up to nn is equal to 2 raised to n minus 1. There are 67 vowels, consonants, and colophons in Prakrit. And there are all sorts of combinations taken together will come to this figure. Yeah. Then lifespan of Rishabha is given as 84 lakh Purva. That is 84 lakh cube. That is a number with 20 years. I have given the digits also. Minimum number of physical audaric bodies of human beings. This is also a very interesting thing, which Anuyog Sutra gives, and then it has come in the Shatkhandagam also. It is equal to 2 raised to 96. And for the first time, Anuyog Sutra displays that we knew the rules of indices, because he says 2 raised to 96 is equal to 2 raised to 32 plus 2 raised to 64. That is 2 raised to 2 raised to 5 into 2 raised to 2 raised to 6, something like that, actually. And this number is a 29-digit number. That also they have mentioned, although they have not mentioned the digits separately, but they have clearly mentioned that it has 29 places. Then the famous number Shirsha Prahelika in Anuyogdwar Sutra and Bhagavati Sutra and many of the agamic works, that is 84 lakh cube. It is a number of 194 digits. Nobody has calculated the numbers earlier. First time we find it in the commentary on Thanang by Abhaydev. First time it has come, and it contains 194. All these digits and followed by 140 zeros. Yeah. Akalanka went further. Akalanka is a scholar from 7th century, saint scholar from 7th century, and he has given a scale which is very similar to Anuyogdwar Sutra and all these scales, but it goes up to 215 digits. It is 84 lakh raised to 31 against 84 lakh 28 of Anuyogdwar Sutra. Then there was a conference in Mathura in 300 AD where first time Anuyogdwar Sutra was edited, and that according to their Mathuri version, there were two conferences, one at Mathura and one at Vallabhi. As per Mathuri version, Shirsha Prahelika is a 250-digit number, that is 84 lakh raised to 36. And then a very significant statement is made there, that limit of counting ends here. And hereafter, if you want to measure the things, they have to be measured by Upama Man, that is Palyopam, Sagaropam, etc., etc. Now, just for interest, I am comparing our modern day figures, large figures. 1 light year, we know, is a 13-digit number given here. Diameter of the observable universe, 93 billion light years, which will come to about 24-digit number. Diameter of actual universe, which is some scientists believe is 250 times that of observable universe, will come to a 27-digit number. Number of protons in observable universe, 10 raised to 80, which is a 81-digit number. Now, let us go direct to the our today's topic with this introduction. What is Alaukik Gadit? It is the modern, in the modern number theory, the field is denoted by Z plus. That is all the integers. Some include 0 also in that, but it is called Z plus. Our agamic scholars, they divide it into 3 main parts. One is Sankhya, that is countable, finite, which we can write, which we can read, and which we can recite. Then Asankhya, that is uncountable, what we call large numbers in the modern mathematics. Some numbers like Graham's number, Ramsey's number, tree 3, they are so huge that no supercomputer also working for in less time can arrive at those figures. Then third is Ananta. These are the 3 main divisions in which the number field is divided in us. Of course, negative numbers were not considered, they were not found practical at that time. So they consider only the positive number field only. Now, as I have already told you, that these have great similarity with the Cantor's ideas of ordinals and cardinals. I am coming to that immediately. And then we will consider the temporal measures, time measurements, that is Palyopam, Sagropam. But they are not necessarily temporal measures. Sometimes they are used in other fields also, in the Kshetra Upma Maman, and all that also. Yeah. Now, Cantor, first I will take you to a very short tour to Cantor's theory of infinite sets. Now, just I have displayed 2 sets, 1, 2, 3, 4, 5, 6, and 11, and then below there the squares of those numbers, 1, 4, 9, 16, 25, 36, 49, etc., etc. So the question is, which set is bigger and which set is smaller? Naturally, everybody will say that the first set is far bigger than the subsequent set, because actually the numbers in the second set, numbers 2, 3 are missing, then 5, 6, 7, 8 are missing, and all that. So there is so much gap. So naturally, the second set must be smaller than the first set. But no, the mathematics of infinite sets is totally different. Galileo noticed it in 16th century, and he first said that both sets are equal. They have equal number, because for whatever number, you have a square. For whatever number in the number field, you have a square. So these are same, which is called cardinality. Cardinality means number of members in the set. And from that point of view, they have same cardinality. And this for cardinality, the infinity he denoted by Aleph Not, which is a Hebrew letter, first Hebrew letter of the Hebrew alphabet. He has denoted it by Aleph Not. And see the strange mathematics. I am not going into various details. There are a lot of derivations, etc. But this, you can treat it, Aleph Not is the first infinity. First infinity. So you add any finite number k to it, it remains Aleph Not only. You multiply it by any finite number k, it again remains Aleph Not only. You raise it to any finite index, it remains an infinity only. Only when infinity raised to infinity, Aleph Not raised to Aleph Not, it comes, then we enter the next infinity. That is Aleph 1. And theoretically, you can proceed like this any number of times. And in one, Aleph 1, Aleph 2, Aleph 3, Aleph 4, all those things you can consider. shown here the various infinities. Now there is another type of infinity also he has considered, which is called ordinality. Ordinality means order. 1, then 2, then 3, then 4, like that. There is not much difference in the cardinality and ordinality. But ordinality considers the order also. And there also, and this is much more common with our Alaukik Ganit, as you will see very shortly, actually. You see, ordinality set 1, 2, 3, 4, it goes up to omega, which is the infinity for the ordinality set. And omega minus 1 is the highest of finite. Now, in fact, omega minus 1 is also omega, but because of the order, omega minus 1 is treated as highest of the finite. Our Alaukik Ganit, when describing this number field, actually adopt this exactly this method. All belong to omega class, and now W omega plus 1, omega plus 2, up to 2 omega, then up to 3 omega, then up to omega square, then up to omega cube, up to omega raised to omega, we come to the higher infinity, omega 1. Up to omega raised to omega minus 1, it is in the first class of infinity. Then similarly, higher order infinity are theoretically defined. Omega 1 raised to omega 1 is equal to omega 2. Omega 2 raised to omega 2 is equal to omega 3, etc. An endless number of infinity. Now, what Cantor, although theoretically it is possible, he could discover only two infinities. One is our regular integers 1, 2, 3, 4, 5, that going to up to infinity. And second is the infinity of real numbers. And he wanted to prove that the infinity for integers is LF naught, while integer infinity for real numbers is what he calls C is equal to N1, but which he could not prove until this is not proved. This is called the continuum hypothesis in modern mathematics, and it is yet not proved, although Fermat's final theorem is proved after 300 years about, but this is yet to be proved. Now, before we go to actual calculations, some algebra for my non-mathematician friend I want to give here. Actually, I want to request my non-mathematician friends that mathematician friend may laugh, but actually for them I'm just giving. And there is some other reason also. Then another rule of indices is 10 square into 10 cube is, we know, 10, 2 plus 3 is 10 raised to 5. In general, am into a raised to n is equal to a raised to m plus n. These are the rules of indices. They are, we all know. Then 10 raised to 10 is 1 followed by 10 zeros, a 11-digit number. It is in the modern terminology, it is 10 billion. Then 10 raised to 100, it is a number called Gogol. It is invented by a 9-year-old boy, a nephew of great mathematician Edward Kastner. It is 1 followed by 100 zeros. These are very, very big numbers. Now, this is the crux. This we are now going to come in our Alaukik Ganit. And that's why it will become simpler, Alaukik Ganit, if we adopt a special notation which is called notes, K-N-U-T-H, notes up arrow notation, the up arrow. But before that, there is one misunderstanding many people commit, even among mathematicians. 10 raised to 10 raised to 10, many people feel it is 10 raised to 100. That is 1 followed by 100 zeros. But no, it is 10 raised to 10 raised to 10. That is a number with 10 billion zeros. Just now, earlier we have seen. It is so big a number. Sorry. Then if this is called height of 10, height of 10 in this notation. So 10 raised to 10 raised to 10 will 10 raised to 10 will be written as 10 up arrows 2. Sorry. 2 means, sorry. 10 raised to 10 raised to 10, where the height of 10 is 3, it is written as 10 up arrows 3. And if there 10 raised to 10 raised to 10 raised to 10 comes n times, then it is written as 10 up arrows n. And it is governed by the recurrence relation. 10 raised to n is nothing but 10 raised to n minus 1. 10n is 10 raised to 10 n minus 1 in Knuth's notation. Just I want to see, we are simply unable to follow, our human mind is unable to grasp these big numbers. So I am just giving you an example. How large is 10 raised to 10 raised to 10? It is 1 followed by 10 billion zeros. 10 billion zeros. I have actually counted, if one types or writes 1 zero per second continuously, without eating, without drinking, without sleeping, or whatever it may be, or by shifts, etc., whatever it may be, it will take 317 years to write this number. If 1 zero per second we write, it will occupy a period of about 10 generations. In 10 generations time this can be done. Now similarly, say how big is 1040? Another comparison I am giving, because simply saying 10 raised to 40 is immaterial. Simply saying 10 raised to 10 is immaterial. But to get the idea, now a very good A4 size paper, its width is, its thickness is 3 by 800 centimeters. That is 3 divided by 800 into 1 lakh kilometers. So 10 raised to 40 pages would pile up to so many kilometers. And we have seen earlier that the diameter of our observable universe is 10 raised to 23, of the order of 10 raised to 23. So it will, I always say, it will intrude into ALOUKIKA or something like that, you can say. Now let us come to our theory proper. The field of positive integers, 2, 3, 4, 5, etc., etc. Now, friends, 1 is not regarded by as a number by our Jaina theory, as well as by some Greek philosophers also did not recognize 1 as a number. They thought that it is a unit, and on which are based all other subsequent numbers. So they started with 2, 3, 4, 5, etc., up to infinity, whatever it may be. It is divided into 3 main categories. One is Sankhyat, which is called enumerable or countable. Asankhyat, innumerable or uncountable. And Anant is our usual term for infinity. Further, Sankhyat is divided into three parts, actually. This is an artificial division, because any set will have a minimum number and a maximum number, and all others are intermediate. But that is the style adopted by our science scholars. Sankhyat is divided in 3 parts. One is minimum, Jaghanya. that is 2. Intermediate, Jaganyanutkrishta, that is 3, 4, 5 up to a minus 2. I am coming to a shortly. And maximum is a minus 1. And a is the minimum of innumerable. So maximum Utkrishta is equal to minimum innumerable minus 1. A is a minimum of innumerables, all innumerable. This is a minimum, actually. No. Sorry. Now, the second division is Asankhya. Asankhya is divided into 3 categories again. Now here, these are the actual categories. Parita Sankhya, I have named it lower order innumerable, but Parit means reached. We have just reached the, we are taking a tour. For example, suppose we are traveling with a train with the speed of light. Suppose I'm just giving an example. So first we'll go to these numbers 3, 4, 5, a minus 2, a minus 1, and then we enter the Asankhya field. That is Parita Sankhya. We enter Parita Sankhya, lower order infinity. Then Yukta Sankhya, that is proper infinity, proper uncountable. And Asankhyata Sankhya, that is, it can be translated innumerable, but I have named it higher order innumerable, which is very, very, very large, which we cannot simply grasp, actually. Now we come to Ananta, the third division. Same way, it is also lower order infinite, middle order infinite, higher order infinite, Paritananta, Yuktananta, and Anantananta. Yes. Each of 3 categories, Asankhya and Ananta, has 3 parts. That is Jaganya Asankhya, Jaganyanutkrishta Asankhya, and Utkrishta Asankhya. That is minimum, and this is again artificial division, but they have divided into 3 parts. So Asankhya is divided into 3, 9 parts. Ananta is also similarly divided into 3, 9 parts. So, and Sankhya has 3 divisions. So total number is 21 divisions. In fact, there are only 7 divisions. Yeah. Now, I am schematically, this will give you to some idea that Parita Sankhya minimum is A. Now, next lecture we are devoting much time on defining A. What is the extent of A? I will give you some idea about that, although it is uncountable. So, minimum is A, then A plus 1, A plus 2, then it will go to 2A, up to 2A, then it will continue to A square, further continues of A cube, etc., up to A raised to A, minus 1 I have made, because A raised to A is the Yukta Sankhya, minimum of Yukta Sankhya. So, A raised to A minus 1 is the maximum. So, Utkrishta Parita Sankhya is Yukta Sankhya minus, minimum of Yukta Sankhya minus 1. So, I have mentioned it B. So, Yukta Sankhya, also B is equal to A raised to A, then B plus 1, B plus 2, 2B, B square, B cube, etc., up to C minus 1, where C is the minimum of Asankhata Sankhya, and C minus 1 is the Utkrishta of maximum of Yukta Sankhya. So, this notation I have followed. So, I have denoted the 3 Asankhatas by A, B, C, minimum 3 Asankhatas by A, B, C, and okay. Then similarly, Paritananta, Paritananta is also C raised to C, means minimum Asankhata Sankhya raised to minimum Asankhata Sankhya will give us a Paritananta. Or in the term of Yukta Sankhya, it will be this quantity. And in term of minimum of Asankhata, that is minimum Parita Sankhya, we can represent algebraically in this manner, where there are about 8 A's. Height of the A's is 8, actually. Yuktananta, Yuktananta you will see, again similarly, D by D. Paritananta raised to Paritananta will give us minimum of will give us Yuktananta, and it can be represented algebraically in this manner in the modern mathematics. Okay, Anantananta, similarly, F is equal to E raised to E, and it can go up to this. Now, this is a very, very interesting observation. According to Anyogdvar Sutra, Bhagavati Sutra, and many other agamic works, there is no maximum Anantananta. I want to take this rather in detail, this aspect, because many Indian mathematicians, scholars, historians of mathematics, they say that whatever it may be, your Anantananta or Yuktananta and all those things, Asankyatas, etc., they are ultimately finite. Ultimately, they can be expressed by algebraic mode or whatever it may be, but they can be conceived in this manner. So there is some number which is not countable, but they are not ananta. The modern concept of infinity is not just there. But remember, that's why Arias and Anyogdvar Sutra and Bhagavati Sutra and other agamic works, they clearly stated that there is no maximum anantananta. That means this will continue and continue up to the last infinity, the biggest infinity, what I mean to say. So this is a rather more scientific treatment. I will, some other critique on that also will take up later. Now, one thing, this is not only a theoretical exercise by our science scholars. They pondered over this, they pondered over the cosmos, they pondered over the various aspects of the karma theory, the finest karma particles, how much the universe contains, how many particles, etc., etc. All those they can, and that's why they came with some concrete examples of this. For example, they say the number of samyas in Avali is equal to B. B means Yukta Sankhyaat, minimum of Yukta Sankhyaat. So, clearly they have mentioned. Similarly, number of souls not capable of liberations, that is abhavya, slightly afterwards I will coming with this, is equal to E. E means minimum of Yuktananta. Sorry. Then number of space points, pradeshas in the universe, loka, is in the class of higher order innumerable, that is Asankhata Sankhya. In Asankhata Sankhya also, it is such a large, huge range that it is towards the higher end. It is higher end. Yeah. Now, they also obtained, now the study of living beings is one of the greatest achievement of our science scholars. And they have divided the living beings into many classes. Actually, there is a 98 daddak in many Shwetambar and Digambar literatures. That is, living beings are classified into 98 types. And they were arranged from lower to the highest, lowest to the highest by operation called Alpa Bahutva. Sat Sankhya Kshetra, etc., the famous sutra of Tatvar Sutra gives that whether it exists, whether what is the number, etc., etc., that in the end comes Alpa Bahutva, that in what order they are, how they are placed ordinally, ordinal infinity, those ideas. So, for example, Asankhyat classes of the living beings, they have mentioned, Tras are Asankhyat. More than that, but Asankhyat are fire-bodied beings, Tejkai. More than that, but in Asankhyat class is earth-bodied beings, Prithvikaya. more than that, but in Asankhya's class is Apakaya. Then comes wind body, then comes space points of the universe. That is the total limit of the Asankhya, we can say. Similarly, infinite classes also, they have pondered very seriously and come out this hierarchy. Least are abhavyas. In this list is abhavyas. There may be others also, which are less than abhavyas. Abhavyas, siddhas, that is liberated soul. Abhavyas means those who have no potential for liberation. A very poor class which can never seek liberation. Abhavyas, siddhas, liberated souls, more than abhavyas or siddhas, but they are all infinite. Siddhas are also infinite in number, which sometimes looks very paradoxical. But then bhavyas, that is soul capable of liberations. Then vanaspatika, plant bodies, they are actually ananta class. Tiryancha, animals, mitha, because tiryancha contain vanaspatika also, that's why they are higher level. Mitha drishti means all these beings, 1, 2, 3, 4, and majority of the 5 indriyas, senses, living beings, they come into mitha drishti classes. Very few, but that too infinite will become siddhas or bhavyas, etc., etc. Then comes sarva jeev. Of course, naturally, that all the jeev come together will be, and then they have significantly stated that the Pudgal Paramanus are infinite times of this sarva jiva. The Pudgal Paramanus are so fine that they are infinite times these infinite bodies. Okay. Now, I will come to, and this is Gobar Sar will have this version. There is slight difference in the version, but there are some defects. That's why I am taking it a little later. According to them, Jaganya Asankhyata Sankhyat, we have not B raised to B, which Yuktananta raised to Yuktananta, but it is B square. But as we have seen, as per the Cantor's theory also, Aleph naught square is Aleph naught. Aleph naught raised to 100 is Aleph naught, etc. So that way it will not go very easy with our modern mathematics. It's smooth with modern mathematics. Similarly, Jagan Anantanant, which I have noted by F, which is Yuktananta raised to Yuktananta, it is not so, but it is E square. Now you will see that how this is a great difference between infinities and asankyatas of Digambar version and Shwetambar version. But no, what they have done, although here it stops with B square, while arriving at Jaganya Ananta Ananta, the method they have adopted is so complicated and is so tremendously bigger that then this C and F, they come to the level of, all have the same level. That means whatever version, both versions, C and F come to the same level. Maybe C and F may be higher also in Digambara version. Yeah. Then this is another thing now. This is the Shalaka Traya Nishtapan. This comes very often in the ALOUKIK GANITA, which is called raising the number to the same number, by the same number, raising a number by the same number. Now, for example, C raised to C. Paritananta, when Asankhata Sankhyat C, when it is defined by Nemichandra as B square, that is Yuktan square of Yuktananta, then C raised to C becomes the first, it is called Ananyobhas. What is the term they have used? Or Vargit Samvargit was used by a number raised to its own scale. So that is first, S1. Then S1 raised to S1 is equal to S2. S2 raised to S2 is equal to S3. just follow that we are raising the number to the same power, to the same power. All the non-mathematics need not worry about this. This is the first Shalaka, first of the Shalakatra and Stepan. Then this S3, in that we add some 6 sets of the same level, That is ALOUKIKA, Dharma Dravya, Adharma Dravya, etc., etc. I don't remember also that, those 6 sets, but they are added and we arrive at T. Now this T is subjected to Shalaka Trandistapan. T raised to T is equal to T1, T1 raised to T1 is equal to T2, T2 raised to T2 is equal to T3, say. And then third time, that is why Shalaka Trandistapan. In T3, this last T3, 4 infinite Asankhya sets are added. And that is suppose n, and then n raised to n, n1, n1 raised to n1, n2, n2 raised to n2. So this completes a Shalaka Nishtapan. And this n3 is called Utkrishta Asankhata Sankhya n3, which is d minus 1. D minus 1. Or Asankhya Utkrishta Sankhya plus 1. Correct. Similarly, for Anant also, Shalakatara and Stapan is taken. This is minimum of Asankhata Sankhya, which is 3 times Shalakatara and Stapan is operated upon, which gives small n3 as the Utkrishta Ananta. And the Shah and Theta are some specified quantities of the same order. They are of the same level. Yes. Now I am coming to how Nemichandra has dared to establish what is the minimum of Asankyatas. That is our A. So he considers this Anavastha Kunda. This Anavastha Kunda is 1 lakh yojan in diameter, that is equal to our Jambudvipas. Then its height is 1 lakh, which is the width of our Chitra Prithvi. So such a kunda is prepared and is filled with rape seeds, sesame seeds. Sarchap, it is called Sarchap. And he calculates how many rape seeds can come into this. So that calculation comes to, by this our modern formula, he utilizes modern formula. Pi he takes as 3, but here pi is not required because it cancels out in the calculation. So whatever pi, that will be the number. So volume V of the kunda is, this is the volume V. And volume V of the sarshap, that is small seed, that is 1 upon this one. So it goes into numerator actually. So it is a big number, which is a 45-digit number. You can see. He calculates this figure actually. That is wonderful. Such a big calculation, he could make it actually. 45-digit number. But he is not satisfied with this. He fills the pit with having forming a heap, as we do commonly, that when we take the things out, then we take in the heap. So this heap is also shown here. And I don't know how he assumes, but probably practically if we see, it may come true also. He assumes that 3 lakh is the circumference by taking pi is equal to 3. 3 lakh yojan is the circumference. And 3 lakh by 11 is the height of this cone. And this volume of the cone he founds by modern formula, pi d square h upon 4, etc., etc. And that figure comes to, volume of the conical heap comes to a 46-digit number. I have shown the calculation, actually. You can verify also. But there he takes pi as 3 like by 11, actually. So this is a 46-digit number. So total number of Anavastha Kund is this heap plus this Anavastha Kund final. Yeah. So total number of seeds come to a 46 number, which let us denote it by not for our subsequent discussion, because we cannot recite this number always. Now, this is the this I will take afterwards. Now, the idea of minimum of asankhyat or utkrisht of sankhyat plus 1 is conceived in this manner. That one seed is thrown starting from Jambudvip to the subsequent seas and islands. Jambudvip, Lavan Samudra, Dhatki Khanda, Kalu Samudra, Pushkar Dvip, Pushkar Samudra, etc., etc. They are asankhyat of. So, one seed is thrown in Jambudvip. God carries those seeds because he is very powerful. He can carry that kund also with him, actually. So he throws the seed in the Jambudvip, the next seed in the Lavan Samudra, Dhatki Khanda, Kalu Samudra, Pushkar Dvip, Pushkar Samudra, etc., for asankhyat seas and islands. So diameter of this island is when N north seed falls in that sea or island, whatever it may be, we don't know whether it is odd or even number. So that diameter of this island we can work out by a simple geometric series, 1 plus 2 plus 4 plus 8 plus etc. up to 2 raised to n naught minus 1. So it is 2 raised to n naught minus 1, 3 into 1 lakh yojan. I have everywhere omitted thereafter 1 lakh because I am taking now here after the discussion in the units of 1 lakh yojan. So this I am approximating because 3 is so insignificant before 2 raised to n naught. So it will be 2 raised to n naught years. Yeah. No, sorry. Lakh yojan, 2 lakh yojan. Then at that, wherever that n naught seed falls, prepare a Anavastha Kund. That's why Anavastha Kund, the name itself is variable Kund. Variable Kund of the diameter of that island or that sea. That is 2 raised to n minus 3 into 1 lakh yojan. And fill it again with the same seas. And once it is filled, put a seed in the in a shalaka kunda. A separate kunda is prepared, which is also of the same dimension. No, this same dimension. It is a measurement pit, actually. Shalaka kunda it is called. Not Anavastha kund, but a separate. Anavastha kund is different from Shalaka kund, actually. So Shalaka kund is only for measuring purposes. So when the Anavastha kund is filled fully, then drop a seed in the Shalaka kund and continue the process. The god continues further and further till the till the all these seeds, 2 raised to n naught, are exhausted, and he prepares a Anavastha Kund, variable pit of which contains N1. And then n1 upon n0 you can very easily prove, because their depth is same, so their volumes are proportional to squares of diameter. So 2 raised to 2n0 upon 1, something like that. So continuing this way, we can say n1 is equal to 2 raised to 2n0 into n0. N2 is equal to 2 raised to n1 into n1, etc., etc. Like this, we will go on. Now, with this, I am going to stop today's discussion. Then it is said that when all these Shalaka Kunda, one only Shalaka Kund, original Kunda, Shalaka Kunda, and all other Anavastha Kunda, when all those n naught minus 1 they are taken together, the total number is minimum of Parita Sankhyaat. That means one less is Utkrishta Sankhyaat. That is the definition. So Utkrishta Sankhyaat, Utkrishta finite number is also so big. So beauty of this is this I have shown here. With this I am going to conclude today's lecture. A is equal to n0 plus n1 plus n2 plus n0, which are going, they are exploding actually to such a level that all together, but I have written, see, they are equal to, nearly equal to n0 minus 1. See, because n1 is so big, n0 you can ignore. N1 is so big compared to n0 that it is like 1 lakh to 1, something like that, even much more than that actually. N2 is so big that n0 plus n1, they can be ignored safely. So it will become n2 only. So n3 is so big compared to n0 plus n1 plus n2 that you can ignore all that. So similarly, n0 minus 1, subscript n0 minus 1 is so big a pit. The number of seeds in that pit is so big that all earlier are insignificant. They are infinitesimal to them. So we can take as n0 minus 1. Yeah. This I will take up, just explain this in the next lecture properly, and we will. So, should we stop? I think.
Okay, very good. No. You are well in time, and I will appreciate that you have given the this Jain mathematics, Alaukik Ganit, with a lot of clarity, undoubtedly. So I appreciate, and really it is a great, wonderful lecture. Now